This is, the 2006 Calculus BC free response questions for the best table group in the class. Question number 2. An object moving along a curve in the xy plane is at position x of t, comma y of t, so it's a position vector at time t where dx over dt equals the tangent of e to the negative t and dy over dt equals secant of e to the negative t for time is greater than 0, greater than or equal to 0. At time t equals 1, the object is at position 2, comma negative 3. Write an equation for the line tangent to the curve at position 2, comma negative 3. So for a tangent line, you're just going to have to use this equation up here, where y minus k equals the slope times x minus h, and they give you h and k here. The colors are coordinated, so all you need to do for this problem is find the slope. That's the only thing that we don't know. But luckily, they've given us dy over dt and dx over dt. So right here, you can see that dx or dy over dt divided by dx over dt is dy over dx, which is also known as slope. So to find a slope, you just need to find this. So if you get this divided by that, you will get secant of e to the negative t divided by tangent of e to the negative t. And then, since this is all this business is happening at time t equals 1, the slope at time t equals 1 will be 2.7805 when you just plug in 1 to both of these t's here, there, and there. You'll get 2.7805. So when you want to write the equation for the tangent line, you put y minus negative 3, which is plus 3, equals the slope, which is 2.7805 times x minus 2. Alright, problem number 2, question B. Question is, find the acceleration vector and the speed of the object at time t equals 1. Alright, so how are we going to find the acceleration vector? So they give us the position vector, which is just x of t, y of t. And then from that, we figured out that the velocity vector would be dx over dt, dy over dt over here in this area. And that's just because it's the first derivative of the position, which gives you velocity. But then if you take the second derivative of the position, you get the acceleration, which is this part. So d2x divided by dt squared, d2y divided by dt squared is going to be our acceleration vector. So how are we going to find d2x over dt squared and d2y over dt squared is our next question. So for this, if you take the derivative of dx, you'll get the second derivative. So if you take the derivative of tangent e to the negative t, you're going to need to do a chain rule. So the first part is going to be secant squared e to the negative t, that part right there. And then the second part is going to be negative e to the negative t, but since just for notation, we're going to put the negative out here in the front. And then to find d2y divided by dt squared, we're going to take the derivative of dy over dt. So we start out with secant e to the negative t. So this is going to be another chain rule. So the outside is going to be secant of e to the negative t, tangent of e to the negative t, and then derivative of the inside, which is just e to the negative t. We're going to make that, the derivative of that is going to be negative e to the negative t, and once again we're going to put the negative out in the front over here. And then since we're at time 1, when we want to find the acceleration vector, we're going to plug in 1 for these t's. So d2x divided by dt squared is going to be negative 0.422529, which we're going to put over here. And then d2y over dt squared is going to be negative 0.151957, which we're going to put over here. So this is going to be our acceleration vector at time t equals 1. And then the rest of the problem, we need to figure out the speed of the object at time t equals 1. So to figure out the speed, since we're given dx over dt and dy over dt, which is going to be the velocities in the x direction and the velocity in the y direction. So to find the total velocity, we're going to have to Pythagorean theorem. So speed is going to be equal to the square root of dx over dt squared plus dy over dt squared. So speed is going to be equal to the square root of tangent e to the negative 1 squared plus secant of e to the negative 1 squared. And that is going to be equal to 1.13891. Problem 2, letter C. Find the total distance traveled by the object over the time interval 1 to 2 seconds. So for this problem, we're going to want to take the numerical integral from 1 to 2 of the velocity. Because when you're taking the integral of a velocity, it'll give you a distance, because essentially what you're doing when you take an integral is you're adding up a bunch of lines. Like on this graph down here, you're adding a bunch of these lines, but tighter together. So it's just like an area. So if you're finding the area of a velocity and time graph, velocity would be measured in something like meters per second, and time would be measured in something like seconds. So when you multiply them together, it would give you just meters, right? So for that, that would give you a distance right there. So when you take the integral of a velocity, it gives you a distance. So to find the velocity in this, it's just like the last problem where dx over dt is the x component of the velocity and dy over dt is the y component of the velocity. So you use the Pythagorean theorem to say that velocity over time, which would be this part right here, would be the square root of dx over dt squared plus dy over dt squared. So we can take this velocity over time, vt, and then we can put in the integral from 1 to 2 of the square root of tangent e to the negative t squared plus secant e to the negative t squared dt. And then since this is a calculator active problem, you can just plug that in your calculator and get 1.05935, which is the answer. Alright, problem 2, letter D. Is there a time t is greater than 0 at which the object is on the y-axis? Explain why not. So for an object to be on the y-axis, it just needs to have x be equal to 0. So we're going to try and figure out if at any time x is equal to 0. So if you graph dy or dx over dt, which is tangent e to the negative t, this is the graph down here for that. If you graph that, it'll show you where the graph is increasing or decreasing in terms of x. So when it's positive, that means that it's going away from 0, and when it's negative, it'll be going towards 0. So for this, from time 0 to infinity, so like anything greater than 0, it's always positive. So that means that the slope is always positive of the position of x. So that means that it's always increasing. So you know that from time t equals 1, since they give you t equals 1, it's at the position 2, negative 3. The x is positive already. So anytime greater than 1, it will be greater than 0 because it's always increasing. It's never going back towards the y-axis, or towards x is equal to 0. Alright, so we know that t is greater than or equal to 1 is always going to be a positive x value and not be equal to 0. So for the rest of the problem, all we need to do is find out if from t is equal to 1 or less towards 0, if in this area it will be equal to 0 in there. So they give us that at time t equals 1, the x value is 2. So all we need to do is we need to subtract 2 minus the integral from 1 to 0 of dx over dt, because the fundamental theorem of calculus says that the integral from 1 to 0 of dx over dt is how far the object will move in the x direction back from its location. So if we do 2 minus that, we'll get the point where it is at 0 in the x-axis. So what we do up here, we do the integral of 1 to 0 of dx over dt, which is tangent of e to the negative t dt, and then when you plug that in your calculator, you get negative 0.77555. So all we need to do with that number is we just need to plug it in, see if 2 minus that is going to be equal to a negative number or not. So we do 2 minus 0.77555, and that gives us 1.2244, which is not negative, which means that any time greater than 0, it will not be x will not be equal to 0. So that means we are all good.
Hello class, this is Jared Fitzen coming at you. We are going to be working on problem number 3. So, the figure above is the graph of function x, which models the height of a skateboard ramp. The function meets the following requirements. And we will go over these requirements as we go through these other additional problems down here. So let's get started with problem A. Let f of x equal a times x squared, where a is a non-zero constant. Show that it is not possible to find a value for a so that f meets requirement 2 above. And if we look at requirement 2, at x is equal to 4, the value of the function is 1, and the slope of the graph of the function is also 1. So let's just get started by writing the function right up here. And it says that at, right here in this problem, at x is equal to 4, the value of the function is 1. So let's plug in 4 to our function, and that is going to come out to a times 4 squared, which is 16a. And since it says the value of the function is 1, that means that this f of 1 right here is going to turn into 1. So 1 is equal to 16a. And let's solve for a. So we will just divide both sides by 16, and we get a is equal to 1 over 16. So now we have the complete function. So when we plug in for x, we can get a value for y. But it says that the value of the slope, or the slope of the graph of the function is 1 right here. So since we're trying to disprove this, show that this isn't true, we want to show that the slope is not going to be equal to 1. So in order to find the slope, we're going to want to take the derivative of this f of x. In order to do that, we're going to multiply 2 times 1 over 16, and it's going to be x to the 2 minus 1, so x to the first, which is just x, when 2 over 16 is simply equal to, this is a 6, is equal to 1/8 times x, which matches right here. And so it says the slope of the graph is equal to 1. So if we were to plug in 4, as it says over here in the problem, at 4, the slope of the graph should equal to 1. So we plug in 4, 1 over 8. 1 over 8 times 4 is equal to 4/8, or 1/2, and that is not equal to 1. So that shows that this requirement number 2 is not true, and it is not possible to find a value for a so that f meets requirement 2. Alright, so now we are going to be moving on to question B. Let g of x equal c times x cubed minus x squared over 16, where c is a non-zero constant. Find the value of c so that g meets requirement 2 above. Show the work that leads to your answer. So again, we are going to be working with requirement 2. At x is equal to 4, the value of the function is 1, and the slope of the graph of the function is also 1. So we are going to start by writing g of x up here, and it says at x is equal to 4, the value of the function is 1. So we will plug in 4 into g of x. So g of 4 is equal to c times 4 cubed minus 4 squared over 16. If we simplify that, we get 64c minus 1, and since the value of the function right here, the value of the function is 1, this g of 4 right here is going to be equal to 1. And then we'll add 1 to both sides to get 2 is equal to 64c. And then we will divide both sides by 64 to get c is equal to 1 over 32. And then we will plug this back into the original equation, which is up here. And we get g of x is equal to 1 over 32 times x cubed minus x squared over 16. And so just to confirm, just to show that the value of the function is 1 when x is equal to 4, we will again plug in 4 into g of x. So 1 over 32 times 64 minus 16 over 16 is equal to 2 minus 1, which is equal to 1. So this shows that when c is equal to 1 over 32, and we plug in x, or 4 for x, the value of the function is 1. So the first part of requirement 2 is correct. So now we need to move on and show that the slope of the graph of the function is 1 when x is equal to 2. So in order to do that, we're going to rewrite the now modified version where we have c in the function, and we're going to take the derivative of this to find the slope at the point, any given point. So we plug in, so we're going to multiply 1 over 32 by 3, then x to the third minus 1 is x squared, which you can see right down here, and then minus x squared over 16 will bring the 2 down, so it'll be 2x, and x to the second minus 1 is just x to the first, so x. So 2x over 16, which simplifies to x over 8, right down there. And then we need to plug in 4, because at x is equal to 4, the slope of the graph should be, or the slope of the the slope of the function should be equal to 1. So we plug in 4, x squared, 4 squared is equal to 16, minus 4 over 8. And then we move on over here to simplify that. So 48 over 32 minus 16 over 32. And this 16 over 32 is just this 4 over 8 multiplied by 4, so we can subtract it from this 48 over 32. And so 48 minus 16 over 32 is equal to 32 over 32, which is equal to 1. So this shows that the slope of the graph of the function is 1 when x is equal to 4, and the value of the function of this original g of x is also equal to 1 when x is equal to 4. Alright, so now we are going to be moving on to question C. Using the function g and your value of c from part B, show that g does not meet requirement 3 above. So now we're going to be looking at requirement 3, which is between x is equal to 0 and x is equal to 4, the function is increasing. So right here is our function g from part B. So g of x is equal to 1 over 32 times x cubed minus x squared. And since we want to figure out whether it is increasing or decreasing between these 2 points, we need to take the derivative of g of x in order to figure out the slope. So g prime of x is equal to 3 over 32 x squared minus x over 8. And this is the same thing from part B. So if you want to see how you get this derivative, you can just refer back to that. And this this section simplifies over here to, or not simplifies, but it gets us ready for our next stage, because what we want to do is we want to factor out an x. So 3 over 32 times x squared minus 4 over 32x. We can turn this into 1 over 32x times 3x minus 4. And so the reason we put it into this form is because we want to find the zeros so we can do the first derivative test to figure out where the slope is increasing and decreasing. So our first x is equal to 0. If we plug in 0 right here, 1 over 32 times 0 is 0, and doesn't matter what this is because it will be 0. And x times 4 over 3 right here 3 times 4 over 3 is 4, minus 4 is equal to 0. And then we do the first derivative test. So what this means is if we plug in, let's say, -1 into this g prime of x, 1 over 32 times -1 is a negative number. And 3 times -1 is -1 minus 4, which is -7. So a negative number times a negative number is positive, which we have right here. We can plug in 1, so 1 over 32 times 1 is a positive number, times 3 times 1 minus 4 is -1, so a positive times a negative, and we can plug in 2, so 6 minus 4 is 2, a positive number, and 1 over 32 times 2 is also a positive number. So you can see that the function g prime of x is negative between 0 and x is equal to 4 over 3. So that means that the function is decreasing between x is equal to 0 and x is equal to 4. And since this problem is also, you can use your calculator on it, if you graph the function g prime of x, you can see that between 0 right here and 4 over 3, the line on the graph is below the x-axis, which means that g of x is decreasing between this area, which is between x is equal to 0 and x is equal to 4. So this shows that g does not meet requirement 3 above because it is not always increasing between x is equal to 0 and x is equal to 4. Alright, so now we will be moving on to the fourth and final problem of question 3, which is D. Let h of x equal x to the n over k, where k is a non-zero constant and n is a positive integer. Find the values of k and n so that h meets requirement 2 above. Show that h meets requirement 1 and 3 above also. So in order for us to move on to questions 1 and 3, we're first going to need to find the values of k and n going along with the requirements of number 2. So at x is equal to 4, the value of the function is 1, and the slope of the function is also 1. So we'll start by writing this h of x that they gave us. So this is just the problem straight out of the instructions they gave us. And since x is equal to 4 and the value of the function is 1, we just do 1 is equal to, we plug in the 4 for x, 1 is equal to 4 to the n over k, and to solve for k we just multiply both sides by k. So k is equal to 4 to the n. Alright, so the next thing that we need to do is we need to show that the slope of the graph of the function is 1. And so at this point we know what k is, but we still don't know what n is. And so before we find out what n is, we need to take the derivative of h of x because we're going to need to see what the slope is to see if it is equal to 1. And along that process, we'll figure out what n is. So we take the derivative of h of x. H prime of x is going to be equal to n times x to the n minus 1 over k, which is just this simply n drop down to the front, so n times x to the n minus 1 over k, because k is a constant and it stays the same. H prime of x is equal to n times x minus n times x to the n minus 1 over 4 to the n, because remember, k is equal to 4 to the n. We found that up in this first section over here. So then h prime of 4 is equal to n times 4 to the n minus 1 over 4 to the n, because this is our k right here. And then this is our x we're plugging in, is equal to n times 4 to the n minus 1 times 4 to the negative n, and this is this 4 to the n brought up to the top, just so you can better visualize how we're simplifying it. So this 4 to the n minus 1 times this 4 to the negative n, the exponents add together, so it's 4 to the negative 1 because the n's cancel out. 4 to the negative 1 is the same thing as 1 over n. So n times 1 over 4. So n times 1 over 4 is n over 4, which is right here. So since h prime over 4 is supposed to equal 1 according to our graph, or according to the directions right here, we see that n over 4 right here is equal to 1. And so that means n is equal to 4. Now in this next step, h prime of x is equal to 4x cubed over 256. All we're doing here is simply plugging in n to our original h prime of x, which is right here. So that h prime of x, we plug in the n, this initial m, and then initial n times x to the n minus 1, which is 3. 4 minus 1 is 3. And then just to prove that our equation is right, we're going to plug in 4. We're going to plug 4 into h prime of x one more time, just to show that the slope of the graph is 1. So we plug in 4 into h prime of x. 4 times 4 cubed is the same thing as 4 to the 4th, which is 256 over 256, which is equal to 1. So this just further proves that the slope of the graph of the function is 1 when x is equal to 4. And it also, back up here, shows that the value of the function is 1. Now our next step is to show how h meets requirement 1. So if we go up to requirement 1, we can see that at x is equal to 0, the value of the function is 0, and the slope of the graph of the function is 0. So right here, we're just going to rewrite what our h of x is with all of the k's and n's plugged in. So x to the 4th over 256. And since at x, since 0 is equal to x, or x is equal to 0, we'll plug that into h of x. So h of 0 is going to be equal to 0 to the 4th, which is 0 divided by 256 is 0. So that shows that, that proves that the value of the function is 0 when x is equal to 0. And then the next thing we want to prove is that the slope of the graph of the function is also 0 at x is equal to 0. So to do that, we are going to want to plug in 0 to this h prime of x that we found over here. And from that, we get 0 again. So this just once again proves that the slope of the function of 0 is 0 at x is equal to 0, and that the value of the function is 0. And moving on to the final part of question 3, part D, we look at this section. So if we look at 3, between x is equal to 0 and x is equal to 4, the function is increasing. So we have h prime of x is equal to 4x cubed over 256, which is once again what we found over here, this whole complete equation. H prime of 0, so the reason we're plugging in h prime of 0 is because we want to find the critical points. So on the y-axis at 0, if the line dips below the x-axis, that means that the h of x is decreasing at that point. So we plug in 0 for h prime of x, and we get 0. Then we perform the critical number test, or the first derivative test, sorry. And so if we were to plug in a number that's less than 0, let's say -1, negative 4 times negative 1 cubed is negative 4 over 256 is a negative number. And if we plugged in 1, 4 times 1 cubed is 1, so 4 over 256 is a positive number. So what this means is that From 0 to infinity, the graph would be increasing. So this shows that between x is equal to 0 and x is equal to 4, the function is increasing because according to our first derivative test, it is going to be positive after 0, between 0 to infinity.
Hey guys, this is Erica, and we'll be doing question 4 of the 2006 AP Calculus BC free response. So, question 4, they give you that the rate in calories per minute at which a person using an exercise machine burns calories is modeled by the function f. So this is the function f, and in the figure above, f of t is equal to negative 1 over 4 times t cubed plus 3 over 2 times t squared plus 1, where in the intervals from 0 to 4, where t is greater than or equal to 0 and less than or equal to 4. So right in here. Otherwise, f is piecewise linear for the intervals where t is greater than or equal to 4 and less than or equal to 24. So question A is find f prime of 22 and indicate the units of measure. So question A, we know that f prime of x is equal to your change in y over your change in x. So keep that in mind. So if we did f prime of 22, 22 would be found in between here. Oh, let me get a different color. Let's see. Okay, you can see it. So f prime of 22 is right here within the intervals where t is greater than or equal to 20 and less than or equal to 24. So since it's linear, the slope should be the same as long as you use the points in between these two. So we're just going to use the given points of 20 and 15 and 24 and 3. So f prime of 22, so it's going to be your change in y, so from 15 to 3, so 15 minus 3, over your change in x, so from 20 to 24. So 20 minus 24, so that gives you negative 3 calories per minute per minute. And yeah, that's just the answer to question A. So question for part B. For the time interval where t is greater than or equal to 0 and less than or equal to 24, at what time t is f increasing at its greatest rate? Show the reasoning that supports your answer. So it's increasing from 0 to 4 and 12 to 16. So let's try 12 to 16 first. Just because it's linear, it's a little more simpler, because we'll be using the same method that we did in question A. You could just find the slope using points and whatever, which is essentially what we're doing, but we can use the same kind of steps. So f prime of x is equal to your dy over dx. So your f prime of 16 is equal to your change in y from 15 minus 9 and 16 minus 12, which simplifies to be 3 over 2 calories per minute. So that's just pretty much our slope. On to the second interval, 0 to 4. We know that it follows this equation, f of t is equal to negative 1 over 4 t cubed plus 3 over 2 times t squared plus 1. So right here, I wrote it down again in this cyan color, and we're going to just take the derivative of that in order to find the rate at which it's increasing. So the only problem with that is we don't really know what we're going to plug in t with, because visually we don't really know where it's increasing at its highest rate. It could be increasing at its highest rate here, here, or here. We don't know. So we have to take the second derivative, which is negative 3 over 2 times t plus 3. And with that, we're going to set it equal to 0 right here. And we had to find out what t is equal to in order to make this equation true. So we just do a little math. So subtract 3 from each side, and then multiply it by 2 over 3, negative 2 over 3 to both sides, and we get t is equal to 2. So when t is equal to 2, we know that it is increasing at its highest rate. So over here, this is where it's increasing at its highest rate. Well, let me just do that in a different color. Right here, we know it's increasing at its highest rate when t is equal to 2. So we get to plug that in into our first derivative. And so negative 3 over 4 times t, I mean not t, negative 3 over 4 times 2 squared plus 3 times 2, which is equal to 3. And that is 3 calories per minute per minute. So that is our second highest rate. So we just have to compare both of these, and we know that this is the 3 calories per minute is greater than 3 over 2 calories minute per minute. So the function within this time interval, when t is equal to 2, it is increasing at its highest rate. Alright, and also our reasoning as to why we set f double prime of t equal to 0 is because, so like 2 is our zeros. So when t is less than, when t is less than 2, so say 1, it'll be concave up. And when t is greater than 2, so like say 3, it'll be concave down. So when you are to graph this on, I don't know, if you were to graph this on a graph, 2, which is our point of intersection, which is also where it goes from concave up to concave down, that is the point at which your graph is increasing at its highest rate. So that's why we know to plug it into our f prime of t. Question 4, part C. Find the total number of calories burned over the time interval where t is greater than or equal to 6 and less than or equal to 18. So this is great. Even though it looks like I have a lot of lines going on here, it's super simple, super easy. So it's just the integral of f of t times dt from 6 to 18. That's just pretty much what it is. But what that means is it's just the area from 6 to 18. So we just have to find that area. So I divided it all into different sections, make it easy on us. So first section right here, our width is 6 and our height is 9. So 6 times 9, which is 54. And then our next section, which I will do in red. So sorry, it is messy, but we'll get through this. So our width is 4 and our height is 9. So 4 times 9, which is 36 right there. And then next we got this whole triangle going on here, but that's fine. So it's going to be 4 times 6 because our height is from right here 9 to 15. So 15 minus 9 is 6. So our height is 6. So 14 times 6 and then divided by 2 because it is a triangle. And then our last section here in purple, our width is 2 and our height is 15. So 2 times 15 is 30. And then we just add it all together. I forgot to include the answer. The answer is 132 calories. Yes, indeed. That's a lot of calories. What a great workout. Alright, question 4, part D, last part. Alright. The setting on the machine is now changed so that the person burns f of t plus c calories per minute. For this setting, find c so that an average of 15 calories per minute is burned during the time interval from 6 to 18. So right here, our barrier is 6 to 18. So now the function has shifted up and down because you're adding c. So we just have to figure out what c is. So in order to do that, let's look back at the original integral that I did for question C. If you guys can recall, I did the integral from 6 to 18 of f of t times dt. So what we did from that is we found how many calories they burn between 16 and 18 minutes. And if we were to divide that by 12, we would find the average um, calories they burned. So now we're going to kind of take that, and then we're going to add C like we did over here. We added C. Let me do another color so that you guys can see what I'm pointing at. So that's not that much of a difference. Let's go orange. So we added C, and then we took that 1 over 12, so the amount of time from 6 to 18, in order to get an average amount. So, so I split it up. So now we have the integral from 6 to 18 of f of t, and then, oh, I forgot that dt. Can't take the integral without the dt. So f of t dt, and then times 1 over 12, which will get us the average calories burned, and then plus the integral from 6 to 18 of c dt from 1 over 12. So that's just to help us out, because we already know how many calories they burn from 6 to 18 minutes, which is 132 calories. We got this from question C. So 132 calories, and then divide it by 12 to get an average of 11. All right, great. So now we're taking this integral, so it ends up being c sub 2 over 12. And so right here, I just brought it over. So it's 11 plus c sub 2 over 12, which is equal to 15, the average amount of calories burned per minute. So that's what we're calculating for. And we're trying to find what C2 is in order to find what C is over here. Alright, so C sub 2 over 12, yeah. So we're just going to be doing some little math calculations from here on out. So we're subtracting from 11 on both sides. And then we're getting C sub 2 over 12 equal to 4. So then C sub 2 is equal to 48. So that's great, but don't make the mistake of saying that C is equal to 48, because it's not. C is equal to 4, actually, because you take 48 and you plug it in right here in order to make this equation true. And when you plug it in, you get 48 over 12, which is equal to 4, and that is what C is equal to. So it's going to be f of t plus 4 is the new equation for our graph.
Hello class, welcome to Math with Devon. We're going to do this real quick like. So, number 5, let f be a function with f of 4 equals 1 such that all points x and y on the graph of f satisfy the differential equation circled in blue. And let g be a function where g of 4 equals 1 such that all points x and y on the graph of g satisfy the logistic differential equation circled in purple here. So we're going to do A first, and A is defined y equals f of x. So in the problem they give us f prime of x, which is dy over dx equals 2y times 3 minus x. So the first thing we need to do here is we need to divide both sides by 2y so we can separate the variables and get, the y is on one side and the x on the other side. So multiply by 1 over 2y, divide by 2y, same thing. So what you get then is dy over 2y equals 3 minus x dx. Then what you have to do is we're trying to find y. So you have to take the integral of both sides since we have a dy and dx, and to take the integral of dy over 2y, you have to do a u sub. So u equals 2y dy and du equals 2. So we have the dy. So we need to add a 2 in here and a 1/2 out here. Oh my. Let me change that too. Okay. So then what you get once you take the integral of that is 1/2 natural log of the absolute value of 2y equals 3x minus x squared over 2 plus c. So what you want to do then is multiply both sides by 2 to get rid of this 1/2, this pesky little 1/2 here. And then what you get is the natural log of the absolute value of 2y equals 6x minus x squared plus c. And what we're going to do here is we're going to exponentiate everything so that we can get rid of that nasty natural log. And once you do that, you end up with the absolute value of 2y equals e to the 6x minus x squared plus c. And then we're just going to get rid of the absolute value bars and make this c2 over here. Right here. And then so e to the x minus x squared plus c is just the same thing as e to the 6x minus x squared times times e to the c2. And e is just a constant. It's just a constant number. So e to the c will also just be a constant number. So this just becomes c, which becomes c times e. So, oh my lord, I'm sorry. There we go. Okay. So then what you get down here is 2y equals c2 times e to the 6x minus x squared. And then what you do is you multiply both sides by 1/2, and you get y equals c3 times e 6x minus x squared. And now what we're going to do is that we're going to plug in 4 and 1 to find c. So x equals 1. Sorry, x equals 4 and y equals 1. And we know this because it gives us f of 4 equals 1. So once you plug those values back in there, you get 1 equals c3 times e to the 6 times 4 minus 4 squared, and that ends up giving you 1 equals c3 e to the 8. And so what you do now is that you divide or multiply by 1 over e to the 8 on both sides. Let's put this right here. E to the 8. E to the 8. And then you end up getting 1 over e to the 8 equals c3. So now you have to plug c3 back into the original equation that we found right here. You got to plug c3 in. And so once you do that, you get y equals e to the 6x minus x squared times 1 over e to the 8, or just all of that over e to the 8. And once you simplify that, you get y equals e to the 6x minus x squared minus 8.
Going into letter B, given that g of 4 equals 1, find the limit of g of x as x goes to infinity and the limit of g prime of x as x goes to infinity. And it says it's not necessary to show our work, but we're going to show our work. So how you solve this problem with the information you're given is to make a slope field. And we can make a slope field because of this differential equation up here circled in green. And this differential equation is g prime of x. So how you make a slope field is you take any point on the graph, for example, this one in green right here, 0, 3, the point 0, 3. And how you find the slope field is you take a point, plug it into this differential equation, which we're going to do right now. So we're going to plug 0 and 3 into dy over dx equals 2y times 3 minus y. So if when we plug this in, that it just ends up equaling 0, because 3 minus 3 is 0, and then 6 times 6 times 0 is 0. So what that tells us is the slope at the point 0, 3 is 0. So what you do is you find the slopes for all the points on the graph that you need, and you make a slope field. So now we have the slope field, and now all we need to do is draw g of x to solve these limits. And how we're going to do that is using the information given to us. We know that g of 4 equals 1, which is also giving us, which is pretty much the same thing as saying we know the point 4, 1 on the graph of g of x. So we know 4, 1 is on the graph of g of x, so we're going to plug it in onto the slope field, which is right here. And now we just have to draw the graph according to the slopes that the slope field shows us. So starting at 4, 1, we see that the slope is around 4. So what we're going to do is draw a line that's around 4 all the way to 2, and going down to around 1/2. And then as we get to 2, we see that the slope is also around 4. So we're just going to draw another line that shows that the slope is around 4, not all the way to 3, but far enough. So now to finish off this graph, we see that the slope goes to 0 as we get to 3. So we're going to assume that the slope gradually changes. So we're going to make a curve here, and it just levels out, but it never passes 3. And same thing down here, as g of x goes to 0, the slope is going to level out to 0. Now we have g of x drawn onto our slope field, and we see here on g of x that there's two asymptotes, horizontal asymptotes. There's asymptote at 3, y equals 3, and an asymptote as y equals 0. So that means that the line will never cross, g of x will never cross those asymptotes. So as x, the limit of g of x as x goes to infinity. Let's look at our graph here. We can see that as x keeps going to infinity, g of x keeps going up. It will never be negative. The slope will always be increasing. It will always be positive. But it will never pass 3. It will never pass y equals 3. It will always approach it, but it will never pass it. That means that the limit of g of x as x goes to infinity is 3. Okay, we found that. Now the limit of g prime of x as x goes to infinity. Now all we have to find is the limit of g prime of x as x goes to infinity. And now that we know the limit of g of x as x goes to infinity, this is so much easier, because all we have to do is use the slope field. So we know that the limit of g of x as x goes to infinity is 3. So that means that the y we have to look at on this slope field is 3, because the point of, let's say there's a point infinity 3, because g of x is never going to pass 3. So if x is infinity, y will be 3. So we have to look at that point on the slope field theoretically. So if this keeps increasing to infinity, the point's going to be at 3. So let's imagine we see infinity here. The y is going to be 3. And what is the slope field telling us when y is 3? It tells us that it's 0. So the limit of g prime of x as x goes to infinity is 0. Going on to letter C. For what value of y does the graph of g have a point of inflection? Find the slope of the graph of g at the point of inflection. Okay, here we go. Easy work. So what you got to do is you got to find the second derivative of g of x. Luckily, they already give us the first derivative right here. So all we have to do is take the derivative of that, and we have the second derivative. So this is what we do. We already did it right over here, and we're going to walk through it together. So here we have dy over dx equals 2y times 3 minus y. The first thing we want to do is distribute this 2y into here. And what you get once you do that is dy over dx equals 6y minus 2y squared. Then what you're going to want to do there is take the derivative of that. And when you take the derivative of that, you get 6 minus 4y. The y goes to 1, and y squared goes to 2y, and 2y times 2 is 4y. So that is the second derivative right here. So now we just have to find the point. We just have to find the y value for the second derivative so we can find the point of inflection. So what you do then is you plug 0 in to d squared y over dx squared and solve for y. So here's how this works. It's just some simple algebra. After you plug 0 in, you're going to add 4y to both sides. 4y to both sides, and you get 4y equals 6. And now all you have to do is divide by 4, or multiply by 1/4. Tomato, tomato. And you get y equals 6 over 4, or 3/2. So this is the y value for the point of inflection on the graph of g. 3/2. Easy. So that's the first part of C. Second part of C. Find the slope of the graph of g at the point of inflection. So now all we have to do is find the slope of this point of inflection right here. Some x value y, 3/2. So we have to plug in this point into this equation circled in magenta and yellow. And we do that right here in the blue. So dy over dx equals 2 times 3/2 times 3 minus 3/2. That is it. That is the differential equation with 3/2 plugged in. And that simplifies to dy over dx equals 3 times 3/2, because these twos divide out into 1, so that's 3 over 1, and times 3 minus 3/2, or you can look at this as 6/2. Sorry about that. That's a bad 6. That is a 6 though. 6/2 over 2 minus 3/2, which is just 3/2. So you end up getting dy over dx equals 3 times 3/2. And when you multiply that out, 3 times 3 is 9. You get 3 times 3 is 9. You get 9/2. And that is the slope of the point of inflection. You're welcome.